Welcome back. So we have come a long way. Look at all the code we've written. Oh my goodness. Replicating a machine learning research paper from scratch with PyTorch. But now we have some main takeaways. So let's go. Oh, went a bit too far. Main takeaways from it. So with the explosion of machine learning, new research papers are coming out basically every day. And yes, as you'll quickly find out, it's impossible to keep up with all of it. But as we've done, we narrowed it down to our own use case. And we replicated a computer vision paper for Food Vision Mini. We stuck with our Food Vision Mini problem. And what I kind of wanted to convey in this section is not really the overall concept of replicating a machine learning research paper, as in it's going to be different per paper. I would rather show you how to do one so that you can take the principles that we've learned here and adapt them to others. So machine learning research papers often contain months of research. That's something to keep in mind. We've seen this before, but this beautiful piece of research is from a group of 12 wonderful people from the Google Research Brain team. So it makes complete sense if a lot of what we've covered in here doesn't quite make sense the first time. I've read this paper probably a dozen, or maybe that's too many, 6, 7 times now, and every time I do, I pick up something new. So the only reason we were able to go through all these steps is because I've had practice reading research papers like this and translating them into code, and eventually you'll be able to do the same thing too. So if we come back, and the goal of paper replicating is to do exactly what we did. We turned text, math, and images into usable PyTorch code. So we could in fact save our VIT, if we go up here, putting it all together to create VIT, we could save this plus some other classes to a Python file, going modular, save it to vit.py, something like that, and then we could just import our pre-trained model. So from VIT, import VIT, and then we would have access to it. So that's the whole goal of paper replicating. Turn text, images, and math equations into usable code. And come back. Many new research papers and teams are starting to publish their codes with papers on one of the best sites. Papers with Code, I read this fairly often. I don't understand 90% of what's going on, but if I find something that's associated to the problem that I'm working on, well then I have a look at it and see if there's code associated with it. Then if we keep going, if we break things down, a research paper in a whole sense can be quite intimidating. But if we break it down into inputs and outputs, layers and blocks, we learn that a layer takes an input, performs some sort of function, and creates an output. And then a block is a stack of layers, and a block takes some inputs and outputs. And then finally, a model is often a stack of blocks. Just like our vision transformer, a single layer could be the multi-head attention layer, then the block could be the transformer encoder, then the overall model could be a stack of transformer encoders. So if we go back down, we've learned a whole bunch in this section. Pre-trained models are available for many state-of-the-art model architectures, and with the power of transfer learning, these often perform very well with little data. So that's what we saw. We just saw how quickly we could get a pre-trained VIT, adjust it to our own problem, and make it work quite well. And finally, we've seen this was the last point we covered. Larger models, which is our VIT model, has 86 million parameters or thereabouts, generally performs better, but it has a larger footprint. So perhaps that is something to ask yourself, is when you want to deploy it, in other words, put it into an application, is that extra performance of a larger model worth it / aligned with our use case? And if we wanted to deploy our Food Vision Mini app like Nutrify.app, so someone could upload an image and have it classified in the browser, perhaps a model that's 327 megabytes is too big for what we're trying to do. Now, that might not always be the case, but it's something to definitely think about. And then finally, there is a bunch of exercises here to try out. There's a template notebook you can see on the GitHub repo, and also a solutions notebook, all linked in the course book. So there's the template. If you want to, you could open this in Google Colab. I'll just wait for that to load. Here's some example solutions. I would highly suggest trying to go through the exercises yourself before looking at the solutions. And you could copy this to your drive. PyTorch experiment tracking exercises. We'll just wait for this to load, and then you could start to write code in the sections where it says to do, your code to do. So replicate the vid architecture we created with inbuilt PyTorch transformer layers. That's a great challenge. And turn the custom vid architecture we created into a script, example vit.py. And if you want to see an example of me going through these exercises, you can come into extras or solutions, and then there's a video here of me going through the exercises live, so you can see all of the errors and whatnot and how I might approach them. So that's available on YouTube as well. And then finally, if you would like to learn more about the things that we've covered, because there were a lot of things that we just kind of went quite quickly through because we were focused on writing code, but there's Vit PyTorch repository, PyTorch's own implementation of the vid architecture on GitHub. There's the fantastic blog post that described more about what's going on behind the scenes for attention and transformer models from Jay Alamar. If you want to learn more about layer normalization, Ardrish Day, there's a fantastic write-up of layer normalization here. And then if you want to keep going with attention, there's the original paper, Attention is All You Need. And finally, Yannick Kilcher's YouTube channel is a sensational resource for visual paper walkthroughs. And there's one for Attention is All You Need. And of course, an image is worth 16 by 16 words, which is the paper that we replicated in this section. Now, congratulations for making it through PyTorch paper replicating. This was the biggest section of the entire course. So pat yourself on the back, and I think it's time to celebrate. So if you've got a partner, take them out dancing. You can tell them all about the Vision Transformer architecture. And if you're single, well, take yourself out dancing, because dancing is fun anyway. I'll see you in the next chapter.